Okay, this is going to be a video on Notes 3B, which talks about the characteristics of a polynomial function. On the screen, I have the worksheet, and I also have Open Desmos. The link is on the website if you have not yet been there. First thing we're going to need to do is type in the equation. So, x, caret key up, which is the shift and the number 6 key. Then we can get our cube in. Bring an arrow down so it comes back down to the main level, plus 6x caret up for the square, plus 8x. And we get this graph. First thing we're going to do is copy that graph over onto our paper. So we need to know where some of these points are. So I'm going to use my cursor, and I'm going to find that there's a crossing at -4, 0. So -4, -1, -2, -3, -4, 0 is an x-intercept. We have a relative maximum just above 3 and just to the left of -3. So just to the left of -3 and just above 3 is our maximum. We have an intercept at -2. We have our relative minimum at just below -3 down and just shy of -1. And we have another crossing the x-axis at 0, 0. So when we put in this graph, okay, not perfect, but close. I should have made that a little more of a curve. Okay, got our graph now from the points. We can fill in the pieces. Our turning points are where we have relative maximums and minimums. So we have a relative max, and that point, I'm going to go back and hover over it, was at -3.155, comma, 3.079. We have a relative minimum at -0.845, comma, -3.079. For our increasing interval, where it's heading up wherever we're going from left to right on our roller coaster, and we're heading up. So we got an increasing interval here and an increasing interval along here. So our two increasing intervals will be, starting from the left is -infinity, and that goes all the way to this x point on the relative maximum, which was -3.155. And then starting at the x point on our relative minimum, 0.845, we are increasing all the way until a positive infinity. The decreasing interval is where we're heading down the roller coaster. So that'll be between these 2 points, -3.155 on the x and a -0.8 4, 5 on the x. Our domain and range, since the graph goes out in both directions to infinity on the x, that means our domain is going to be all real numbers, and we write that with the capital R with the extra line for bolding. Range is the y values, and as we can see very clearly, it's going all the way down to negative infinity and all the way up to positive infinity on the y. So again, all real numbers. Parent function is just what is the highest power we got going here. In this case, it's x cubed. So our parent function in function notation, f of x equals x cubed. That is our highest power of the function. End behaviors, we've got two of them. We've got, as we go towards the positive, we always write the positive first. So as x approaches positive infinity, our y value, f of x, is heading towards, as we're going this way, our y value is shooting up to infinity. In the opposite direction, as x is heading towards negative infinity, so we're heading backwards on the graph, our y value is heading down, so it is heading towards negative infinity. And the last thing we need are our zeros. Zeros are the x-intercepts, and we see that there's a 0 at -4, a 0 at -2, and there was a 0 at 0. We write those as a solution set, -4, -2, and 0.